All right, you're done. And let's see how we all did. So let's see. A 50 milliliter sample of gas. We said that milliliters was volume.
Mm-hmm.
Is collected at a temperature of 15 degrees Celsius.
Mm-hmm.
So we said temperature is 15 degrees Celsius, but
we need to be in Kelvin.
Yes.
The reasons why are a little past the scope of this, but the important thing is we need to be in Kelvin. Kelvin, luckily, very easy conversion. All we've got to do is add 273.
So that gives us 288.
Mm-hmm.
Okay.
All right.
All right.
So then, next thing we know...
And a pressure of 0.987 atmospheres.
Mm-hmm.
What would be the pressure of the gas if the temperature is increased to 30 degrees Celsius?
Mm-hmm.
Okay.
So we
want
have
to
a...
know what the new pressure
Mm-hmm.
is, and we have a
T2.
We have a T2, which is 30 degrees Celsius.
So do our 30 degree, write down our 30 degrees Celsius. What are we going to have to do? We're going to have to add
273. So that gives us 303
Kelvin.
All right.
All right. But
okay.
what did it tell us to assume about the volume?
Assume the volume remains constant.
And again, we mentioned earlier, anything that's constant or anything not mentioned, we don't care. It goes away. So we can cross out the volume it gives us.
And we don't have to worry about the new volume because it doesn't change.
Right. And then what else don't we care about?
The number of moles.
Number of moles, because it
Okay.
never came up.
So looking at our, let's see, PV over NT over into T2.
All right. So what do we need to take out?
Let's see, we need to take out the volumes.
Mm-hmm.
You'll need those and the number of moles. So we're only left with the pressure and the temperatures. Did somebody call in the cavalry or something like that?
Apparently.
Okay.
All right.
I'm just hearing.
So now we're going to take and plug in everything.
All right.
All right. So we plug everything in like we just figured out we needed to. Our pressure 1, which was 0.987
7.
over
The
our
temperature,
T1.
which was 288. We got to make sure we use the Kelvin, right?
Mhm.
Okay. Equals, let's see, we're looking for the new pressure.
Mm-hmm.
And the temperature changed to 303 degrees Kelvin.
All right. So again, this is one of those cases where you actually get to
Cross multiply and divide. Don't mind if I do.
well, and this one's a nice easy one because there aren't extra numbers. All right. So we cross multiply 0.987 times 303 divided by 288, and we get
1.04 ATM, because that is the units that we started with.
okay. So the nice thing is this is another one we can logic check. So our temperature did what?
The temperature went up. That means the molecules are moving faster.
Mhm.
And that means
They're hitting the
They're hitting the
walls.
walls harder.
Harder.
And that's going to make the pressure go up,
Mhm.
which it did.
Yes.
Okay. Awesome.
All right. So one more problem.
Okay. A balloon holds 5 moles of gas, so that is the number of moles, 5.00 moles, with a volume of 125. So we can put that down for the first volume. If enough gas is added to expand the volume to 175 liters, that means we want the new volume to be 175. How many moles of gas are now in the balloon? So we want the number of moles.
And then they were very, very nice in this one, and they told us,
Assume temperature and pressure are constant.
so they have just told us flat out we can ignore temperature and pressure. So
Okay.
if we set up our equation, nice in our little corner here, we have P1, V1, N1, T1 equals P2, V2 over N2, T2. All right, so what can we cross out?
We can cross out temperature and pressure.
So because they're both constants, so they're not going to affect. So we have V over N equals V over N.
All right.
So our V is
125
over our N, which is
5 moles
mhm.
equals the new volume, which is 175, and we want to know how many moles that would be.
And here's another pretty cross multiply divide sort of situation.
Let's multiply and divide.
So our new number of moles
Is
7.
7.
And it told us what?
If enough gas is added to.
So it says we were
how many
adding
moles?
gas.
Yeah, we're adding gas. How many?
So if we're
moles?
adding gas, so do we have more moles or less moles?
We should have more moles.
And so-
more moles means more matter. That's gonna take up more space. So the volume went up.
Right.
Okay.
So all of our numbers make sense.
Cool.
There we go. So
That was remarkably
See?
easy.
there's a lot of variables you can be using, but most of the time we won't be using all of them. Cross out anything that's constant. Cross out anything it doesn't mention, because clearly you can't plug anything in that you don't know. And then just plug everything in, do your algebra. That's going to get you through this whole section.
And then you can go back and tell your algebra teacher that you're actually using something that you learned.
All right, so go try the independent practice now. Ask your teacher if you got questions.